Hello, my name is Kyle Demanis, and I'm here to present about a lecture called Consider the Icicle held by Stephen Morris near the beginning of the semester. So the reason that I chose to attend this lecture is because you always see in movies like icicles hanging from ceilings, and so when I heard about it, I actually realized that I didn't really know much about it. So being able to learn a little bit more I thought would provide some insight. So what is an icicle? An icicle is a long extension that is grown when latent heat is transferred and removed into the surrounding area through a thin film of water flowing down around its surface. There are three primary components of an icicle. There's the ice, then there's the surface layer of water around it, and then the vapor and air that surrounds it. Alright, so to talk a little bit about an icicle structure, an icicle is essentially a pipe. So the water kind of funnels down and gradually just drips off at the end, because actually if the water doesn't drip out at the tip, then it's not considered an icicle. So how do these icicles grow? Well, there are three primary types. The water can drip to the very tip and through bulk just go ahead and build up that way. Or there can be radial growth. Well, through a thin film it will get wider and wider, so the radius grows from the outside. And then there's also something called pipe filling, which from the inside the icicle will grow in diameter. So some things that people confuse with icicles are stalactites and stalagmites, which are actually found on the ceilings of caves and their floors. So what are some differences between these two? So we talked about the three different ways that icicles can grow. Well, stalactites can only primarily grow through length, so they only get longer through the pipe funneling in the tip. And also, stalactites can be able to create different structures that icicles cannot, such as travertine terraces and drapery, which are cave formations that form specific shapes. So all these stalactites can do, but icicles cannot. So a big reason for this is because icicles generally grow really violently and really quickly, as opposed to stalactites, which grow very slow and gently, so it allows them to form more complex shapes. So there's something called the Platonic icicle shape theory, which essentially says that all icicles will have the same emergent shape when they're forming. Now, this isn't true for all icicles, but it has been found for quite a few of them, and so if they are, and they fit this formula and they fit this shape, then they're called platonic. Now, Stephen Morris does a lot of experiments, and in order to determine what's platonic and how to create actual icicles, he's actually created over 250 icicles in his lab, and he did this using an icicle machine. And so what this is, it's a slow rotating dowel that's off an axis, and it has water dribbling over it. And so as that is, it hardens and forms, and there's a fan moving around the air to go ahead and give it a solidified shape. So something that he found as a result of doing these experiments, that the length of the speed growth depends highly on the temperature. And once the tip actually reaches a certain point, it begins to grow outward, which thus becomes less platonic, as we discussed earlier. So another experiment that Mr. Morris ran was using distilled water versus tap water, and he found that distilled water was actually closer to platonic. But something that he also noticed was that tap water seemed to have ripples. So it's essentially little rivets throughout the icicle. And so he wanted to figure out what exactly the cause of that was. In the past, scientists have found these ripples on icicles, but they always thought it was due to either surface tension or the fact that it just wasn't distilled water. And so they didn't really quite know for sure what the cause of those ripples were. So Mr. Morris, again, has tried an experiment to determine what these ripples essentially come from. So Mr. Morris actually had a theory that it was NaCl that caused these ripples in the icicles. So what he did is he created an experiment. He used water with a lot of ACl and actually noticed that there were a lot of ripples that resulted from it. He also tried distilled water with and without air factors, and there were no ripples. He tried using Triton X, which is a component that reduces surface tension. And so by doing that, he was trying to test that other theory of whether or not surface tension was a factor, and he saw that there were no ripples as a result of that. But then he tried another experiment where he combined both Triton X and NaCl, and he actually saw that there were ripples, but they weren't as big. So that just shows that it's the NaCl that's actually causing these ripples and not the result of surface tension. Alright, so in summary, in his entire presentation, essentially, pure water icicles can be close to the platonic theory shape. Icicles can stop growing after a certain point, and they deviate from this whole platonic theory as we discussed. And ripples are due to ionic impurities, so from NaCl being present in the water and all that other impurities. And really, as of right now, there's no really good theory to go ahead and define what makes an icicle, and that just needs to be researched further in the future. So following this presentation, actually when I watched movies, I had a further insight into what exactly icicles were, and actually I was able to differentiate between stalactites and icicles, which was very interesting. So I hope like in the future I'll be able to recognize these differences, and hopefully I'll be able to, if I have any questions, be able to reach out to Google or even out to Stephen Morris in case I have any further questions. Thank you for your time and have a good rest of your day.